Hello, welcome to this video recording of the Webots simulation. My name is Andrew Chorney and I prepared this Webots simulation for the assignment for robotics and machine vision uni course at USQ. So right off the bat here you can see that robots just grappled for the ball and the purple robot managed to shoot and score a goal in here. So the purpose of this video is to do a bit of commentating on the robots and their behaviours and try to explain sort of what the robots are doing and kind of how they work and why they're exhibiting certain behaviours that they do. So you might have seen that even the blue goalie and the blue attacker were both sort of grappling for the ball. Both of them were going after the ball. That's because the number one goal is to go after the ball, and there is a little bit of obstacle avoidance in there, but it takes second priority of trying to get the ball. So fundamentally, these robots work on kind of a state machine in a sense. They're not quite state machine because there are some other behaviors that are controlled outside of the state machine. A good example of what just happened there with the blue robot, it sensed that the ground had turned purple, which is the opponent's color, and then it triggered a separate state called retreat, which makes it go back to halfway until it sees a white mark on the ground at the halfway point. Another example is what you see the purple robot doing here. It's trying to avoid that wall, but at the same time it's trying to grab the ball. So it was kind of just bouncing off the wall there because the two systems were conflicting with each other. But yeah, other than these main behaviors you see from the robot, most of the robot way of acting is controlled by the state machines which operate them. So the attacker's state machine, simply the default one will be that it tries to find the ball and it will chase the ball. So see the purple attacker there is spinning around. It's trying to detect the ball with one of its cameras. So it's got 3 cameras on the front. If one of the cameras, say the left one, for example, detects the ball, then it knows to turn left to find the ball. And then once it's found the ball, once it's lined it up with the middle of its middle camera, then it will drive forward towards it. It makes slight adjustments to its course depending on which cameras are seeing which ball, and it'll keep chasing the ball until it's able to grab it. So as you can see there, the blue managed to score a goal directly, which is pretty good for the blue team. So yeah, once the attacker is close enough within range to grab the ball, it triggers another state which is called grab. So that basically will grab the ball. Once it's detected it's grabbed, then it will trigger another state which will aim. It'll turn the robot until it's aligned with the enemy goal. And the way it aligns itself is there's actually a camera that points slightly up, which detects a certain color. So if you notice the blue goal there is going right up to the sky, that's so the purple robot can detect that blue color with the camera that's pointing up. So the aim state will turn the robot until that camera spots the color that it's after, and then it will stop turning and go to the next state, which will open up the grabbers. And once they're open, then the next state will be triggered while the robot is put into drive forward, and that next state will monitor the acceleration of the robot. So it looks for a very aggressive acceleration. Once that's happened, then it applies the brakes and then looks for another aggressive deceleration. And then once the robot has decelerated, it triggers the next state back to the follow the ball state. There are 2 other states which are independent, which are called by some of the other edge case scenarios which are outside the state machine. One of them I mentioned earlier was the retreat state, when it goes on the enemy's goal area. The other is when the robot is detected that it's stuck. And the way that works is it's got several sensors all the way around the robot pointing in different directions. The way that works is all of those sensor values are added together, they're summed, and then it will keep track of that value over several loops. And then if there's you can see the defender there got stuck in a loop where he's going around and around, I just reset it there and he'll go back to his home position. So the stuck state will be triggered when that summed sensor value will, if that value is less than a set amount for a number of cycles. So for example, if it senses anything within its range, say over 50 cycles, then it will trigger the stuck state, and the stuck will look at whatever sensor is being triggered, and it will try to drive in the opposite direction to whatever it is. So if it sees something in front of it, it'll try to reverse, and vice versa. I've added a thing since the report which after 50 cycles of trying to drive in that direction and it doesn't work, then it'll change the motor direction to the opposite for another 50 cycles before it'll reset out of the stuck state. Another way to reset is if all the sensors are cleared, there's nothing around. So the defending robot operates in a similar way, except there's more states added to it. So its default state, the defender's default state, is to stay still and to basically watch and keep an eye on the ball to see, to monitor the ball's location. Hey, we got another goal. So once the ball is within range of the defender, which is roughly 2 meters, I think, then it will trigger a different state, which is identical to the attacker's state. So then instead of it staying still, it'll then chase the ball and try and grab it and shoot it towards the enemy goal. Once it's done that, then it'll trigger a return state, which will try to drive directly to that white mark in its own goal. It'll turn towards its own goal and drive towards that white mark. And then when it senses an object at a certain distance in front of it, it'll trigger the next state, which will then turn it directly towards the wall on the side, and then it will then look at its front and rear sensors, and it looks at the difference between the two, and then will drive forward or reverse to try to get these values to match. If that value is too negative, that means it has to reverse a long distance, then it will actually flip its bearing 180 degrees, so then it will turn around the opposite way, so it'll drive forward. That's only a temporary measure. On that note too, that technique of flipping the sensor bearing is actually the difference between the purple and the blue teams. There's one variable in the code which, when it's set to either blue or purple, it'll make the sensors interpret the bearing locations 180 degrees opposite of each other. And also that setting will also make the robot look for different colors. So for example, the blue attacker will look for a purple goal, and the purple attacker will look for a blue goal, as an example. There's more examples than that, but that's one example. Anyway, back to the defender. Once it aligns itself with like side to side, then it will turn facing opposite direction towards the enemy goal, and then it will either reverse or go forward to a set distance, and then it'll then be on its white dot. That white dot there, when it's in its watching state looking for the ball, if it doesn't see white there, then it will trigger those states where it'll return back to its white dot. I've also added something in there too where if it spots the ball while it's trying to return, it'll go back to its location. So there you can see the defender is on the green ground trying to chase the ball, but then it turned around and goes to return back to its home position. So what happened there is there's a camera underneath each robot looking down at the ground which it's on, monitoring the color. So for that defender, if he sees any color but white or his home color, then it will start a counter, and if that counter exceeds 50, then it will stop whatever it's doing and return back to its home position. And the idea of this is that the defender doesn't just chase the ball all the way down to the other side of the map. So yeah, they're having a bit of a tussle there behind the wall. We can't really see what's going on there. Another thing to mention is the defending robot there will try to look towards the opponent's goal to find the ball, and after a while, if it can't find the ball, then it'll spin in circles to try to find the ball. The reason for this is it may be trying to look towards the enemy location, the opponent's goal, for the ball, and the ball's right behind it. So after a while, if it can't find it there, it'll turn in circles to look for it in all directions. The other thing about the defender is it's actually got quite a number of distance sensors that are pointing forward, and they're all very, very closely aligned to each other. They kind of spray out in front of it. The idea there is that it's not just relying on one single beam to trigger its defensive mode, that it's the ball would trigger at least one of those distance sensors in front of it. So there's no way that the defender won't chase the ball when it's within range. Sorry about the flickering there. My computer needs an upgrade. It's a little bit old, but so as you can see, the robots somewhat do try to avoid each other if they can, but the problem that's occurring is the ball is actually slightly taller than the robots, so the sensors can't see past the ball, and the problem with that is it's not able to see the robots behind the ball while it's trying to grab the ball. So if I were to do this simulation again with different robots, I would probably choose a different ball or a bigger robot, and then have some robots that are lined up with the ball in the height, and some robots that are slightly higher. Some sensors that are slightly higher, in order to sense objects that are further than the ball. That way you can avoid objects that are beyond the ball. So you'll notice there the purple robot just had the ball and then let go of it and reversed away from it. That's because the stuck state would have been triggered. It was stuck there, and then it tried to avoid the nearest object, which was the ball, and then it reversed away from it. Alright. One more thing too, that if I were to do this simulation again, I would probably choose a robot that doesn't have wheels protruding out, because they often get stuck on one another, and that could be avoided with a different kind of robot. And we had one more goal there, and then that's the end of the video. So thank you so much for taking the time to watch this video, and have an awesome day.